So here we proved our Pythagorean identity, which is this, right? So now we can use that identity to further aid us by finding different versions of this identity. So we know the identity is cosine of theta squared plus sine of theta squared equals 1. So now from here, what we can do is, if we wanted to get it in terms of sine, say we're trying to solve an equation or something that we wanted to get everything in terms of sine, but we had cosine in the game, or if we wanted to get everything in terms of cosine but we had sine in the game, we could say, what we could do is we could take this identity and we could subtract cosine of theta squared over to get sine of theta squared by itself, and we would get sine of theta squared equals 1 minus cosine of theta squared. That would be our first version of it, because like if we had an equation that we're trying to solve for cosine, but it had a sine in it, we would use this to put everything in terms of cosine, and that would help us out. So here we can do the same thing with cosine of theta squared. So if we wanted cosine of theta squared by itself, we could say cosine of theta squared equals 1 minus sine of theta squared. Now again, all I did was just subtract sine of theta squared over from that side. So now we can continue to do this process to get it in terms of different trig functions, but this one's going to be a little more, the next few are going to be a little more involved. So we'll start with our base function, right? The identity. And we'll say, because it's cosine of theta squared plus sine of theta squared equals 1. Now if we take this, divide both sides by cosine of theta squared, we'll get it in terms of something else, because this is really both of these being divided by it, right? So this divided by this is going to be 1. This divided by this is tangent, right? Because sine over cosine is tangent. So this is sine squared over cosine squared, so it's going to be plus tangent of theta squared equals 1 over cosine. So what's 1 over cosine of theta? Well, will be the reciprocal of cosine of theta, which we have a name for, and that is secant. So because this is squared, this is going to be secant of theta squared. That'll be number 3. But now if we take this and we subtract the 1 from this side, we can get tangent by itself and get in terms of tangent of theta squared. So we say tangent of theta squared is equal to secant of theta squared minus 1. So now this time we divided by cosine of theta squared. So if we come over here, what we wanted to do, we could try and do it by, and just write this out again. If we wanted to divide by sine of theta squared, that would give us a whole nother one. So we'll say sine of theta squared, and we're doing it both sides by, so we don't actually change anything, we're just rewriting it a different way. This is going to simplify to cotangent, right? Because tangent is sine over cosine, but the reciprocal of tangent, is cosine of theta over sine of theta. So this is going to be cotangent of theta squared, right? Because these two are squared, plus sine of theta squared divided by sine of theta squared, which is 1, equals 1 over sine of theta squared, which will give you the reciprocal of sine of theta squared, which would be cosecant of theta squared. Say cosecant of theta squared. And now we have this, And if we wanted to get this in terms of just cotangent, all we would have to do is subtract the 1 over. So that would give us cosecant of theta squared minus 1 equals cotangent. That's the different forms of the Pythagorean identity.